Hello, this is the Business Analytics midterm review. We started out by defining business analytics, and we said that it's changing a business problem into a data problem. And with descriptive analytics, we're asking the who, what, where, when questions from past data. And there's several approaches to that. To descriptive analytics, we can do a data query, which is a request to a database. Data dashboards, these are a combination of tables, charts, maps, and summary statistics that are updated as new data become available. Data mining, that's where we're finding patterns and relationships that exist in large data sets. We've stressed that one of the most important things we can do when analyzing data is start with a data visualization. And that involves either creating a summary table or generating charts to help analyze and interpret the data and learn from it. Data visualization is helpful for understanding our data set, highlighting important relationships and trends, and also for identifying data errors. Tables are something we use in data analytics when the reader needs to refer to specific numerical values, they need to make precise comparisons, or the units have very differing magnitudes. We have several types of charts or graphs, and this is a visual method of displaying data. A scatter chart is what we use to represent a relationship between two quantitative variables. A line chart is useful for time series data, and of course we've used those for both types. A trend line is something we can put on a scatter chart, and it shows an approximation of the relationship between two variables. Sparkline is a minimalist type of line chart. It has no axes and it takes up very little space on our worksheet. We also have bar charts and column charts that we can use to display the magnitude of variables. One thing to note is graphs are not used when the reader needs to make precise comparisons. Tables are a better choice for doing that. In our chapter on probability, we went over that uncertainty is something that we always will have in our business decision making, and therefore we'll be dealing with probability, which is a numerical measure of the likelihood that an event will occur. So probabilities are going to be assigned on a scale from 0 to 1. A probability near 0 indicates that an event is quite unlikely to occur. A probability near 1 indicates an event is almost certain to occur. The highest uncertainty is at 0.5 or 50%. In social sciences, and business is a social science, experiments are statistical because we get different answers every time we ask the same question. Statistical experiments are sometimes known as random experiments. Here we see a joint probability table, and it gives the probabilities for both a value in one dimension occurring and a value in another dimension occurring, as well as the overall probabilities for each value in each of the dimensions. So here we've got two dimensions. The top along the columns is does a person default or not default on a loan? And then in the rows, we have the dimension of marriage, the values being married or single. So the cells in the table where we have intersections are going to be the probability that you're married and you do not default, would be the 21.33%. Married and you do default is 26.33%. Single and you do not default, 38. Single and you do default is 13. And this is of your overall probability out of the total. What we see in the margins, well, the margin for no default is 60%. So 60% of the people do not default on their loans. 40% of the people do default. This is the column total for the default value. Likewise, the marginal probabilities for the rows, the probability you're married is 47.66%, and the probability that you're single is 52.34%. So when values are given the probability of the intersection of two events, the probabilities are called joint probabilities. Marginal probabilities are formed by summing the joint probabilities in the corresponding row or column of the joint probability table. And a conditional probability is computed as the ratio of the joint probability to the marginal probability. We discussed several discrete probability distributions. An interesting one is the Poisson probability distribution. It's useful in estimating the number of occurrences of an event that occur in a specific period of time. This is something that happens quite often in business. Number of patients who arrive in an emergency room in an hour, number of computer server failures in a month, highway repairs per 10 miles, and so on. Now, the Poisson distribution is discrete, and it deals with the number of occurrences in a fixed period of time. The exponential distribution is continuous, and it deals with the time between occurrences of successive events. And again, time flows by continuously. The Poisson distribution is discrete. The exponential distribution is continuous. When we look at the relationship between variables, we have to define certain terms. A dependent variable is a variable that we're interested in, and we measure it because we have that interest in it. An independent variable is an indicator variable, and it's something that will affect the value of the dependent variable. Now, one way we can specify a relationship so that we can make predictions is with a simple linear regression. Obviously, we're going to do a data visualization first and make sure that a linear regression is going to be a good model. So a linear regression is one for which a unit change in the independent variable x is assumed to result in the same change in the dependent variable y. In other words, y is going to have the same change each time that a unit change happens in x. Y's change could be 2 times the change in x, 3 times, but it's going to be the same each time. A simple linear regression is bivariate. You have one dependent variable and one independent variable. A multiple linear regression is where you have 2 or more independent variables. So here's the type of model we get. It's an equation of the form y, our dependent variable, is equal to the y-intercept, beta sub 0, plus the slope of the line, beta sub 1 times x, plus some error term. For a multiple regression model, we get not just one independent variable, but multiple independent variables and a slope of the line for each one of those independent variables. Multicollinearity happens with multiple regression, and it refers to the correlation between independent variables in a multiple regression analysis. So you want to have a relationship or correlation between the dependent variable and each independent variable, but you don't want a strong correlation between independent variables. When you get that, you have the problem of multicollinearity. Okay, let's do a problem because you will have a word problem, and it'll be similar to what you see in Chapter 5, Question 6, and that's on page 210 of your text. So take a moment and get to that page on your text, and we'll start going over this problem. It deals with joint probability tables. And again, it's on page 210 of your text. So it says more than 40 million Americans are estimated to have at least one outstanding student loan to help pay college expenses. Not all the graduates pay back their debt in a satisfactory fashion. Suppose that the following joint probability table shows us the probabilities of student loan status and whether or not the student has received a college degree. So let's go to the next slide, and we see that joint probability table. Okay, and then there's a series of questions we can answer using the joint probability table. So the first one, A, is what is the probability that a student with a loan had received a college degree? So here we're looking at, did the student receive a college degree? So that probability is going to be a marginal probability, and it's going to be the marginal probability for the column yes. So college degree, yes. We're going to get college degrees that are satisfactory and delinquent on their student loans, and we get a total of that, and 42% of the people received a college degree. So that's answer A. Then question B, what is the probability that a student with a loan had not received a college degree? Well, again, that's going to be our marginal probability for the column no. It's going to be this margin, and they call it margin because it's at the end of a column or the end of a row. So we look at the no, and again, if you did not receive a college degree, you'll be having both loan statuses, satisfactory and delinquent. So the probability that a student did not receive a degree is 0.58 or 58%, and hence we get this answer 0.58. Next, we're going to look at a conditional probability, and that is question C, given that a student has received a college degree, what is the probability that the student has a delinquent loan? So we know that the probability of a conditional probability is equal to the joint probability divided by the marginal probability. So it's given that a student received a college degree, that's the given. So this is what we divide, the probability that they did receive a college degree. That's our denominator. And then our joint probability is just the intersection of delinquent and they received a college degree. Let's take a look at that table again. Delinquent status over here, received college degree. The intersection is there, 0.16. So the conditional probability is 0.16 over 0.42, or 38.10%. Okay, for question D, given that a student has not received a college degree, what is the probability that a student has a delinquent loan? Well, in this case, the given is that they did not have a college degree. They did not get a college degree. So that becomes our denominator in our equation. In other words, the conditional probability is going to equal to the joint probability divided by the marginal probability, and it's going to be the marginal probability of the given, in this case, given that they did not get a college degree. Well, we got 0.58 for that. So what's the joint probability that they did not receive that they're delinquent and they did not receive a degree? Well, delinquent and did not receive a degree, delinquent and no, is going to be 0.34. So we have 0.34 divided by 0.58 equals 0.5862, or 58.62%. And then lastly, the impact of DROC being out of college is an interpretation. And it basically, as we see here, not obtaining a college degree will lead to a greater probability of struggling to pay back your student loan. Okay, thank you.